So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask code at this side. So today's problem is aggressive cows. It is again a binary search problem. So GFG is trying to master your binary search. So that is why it is giving you binary search problems from the very starting. But for now, forget this is a binary search problem and let us deal with the problem. What does the problem say? The problem says that you have been provided with an array. This is the array you have got. So let me plot this array. It says 4, 2, 1, 9, 8. This is your array, right? Now the array says that these are the position of stalls. Position of stalls. That is, stalls are inserted on this position. That is, if you assume this is a number line, so 0, 1, 2, 3, 4, 5, 6, 7. This is actually this is 8, and this is 9. I mistakenly wrote it in the reverse order, right? If you assume this number line, then there are points 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. etc. But the points mentioned in the array are the stalls. Stalls are inserted on these points. First stall, second stall, third stall, fourth stall, fifth stall, right? Now, you have some cows. You have k number of cows. Number of cows. Each cow has to be allotted one stall. Each cow, one stall. That means your k is always gonna be less than equals to size of your array, because size of array is number of stalls, right? Evidently number of stalls. A stall is already at 4, one stall at 2, one stall at 1, one stall at 9, one stall at 8, and you have 3 cows. Now it wants you to give you it wants you to give them maximum distance between two cows. What I'm trying to say is, suppose, like, what are the configurations you can choose? You can say 1, 2, and 3 are placed here. This is the first configuration. Second configuration, 1, 2, and this. Third configuration is 1, 2, and 9, right? So let me write down. So what you have for the given problem, 1, 2, 4, 8, 9, what can be the possible? You place at 1, you place at 2, you place at 4. You place at 1, you place at 4, you place at 8. You place at 1, you place at 4, you place at 9. You place at 1, you place at 2, you place at 8. And many more, and many more. These are some of them, right? These are some of them. You can randomly assign. Now if you see, these two cows are present in 1, 2, 4, right? One cow, second cow, third cow. What is the distance between them? So these two have a distance of 1. These two have a distance of 1. Among these distances, that is 1 and 1, what is the minimum distance? 1, right? Now, here 3, here 4. What is the minimum distance? 3. Here 3, here 5. What is the minimum distance? 3. Here 1, here 6. What is the minimum distance? 1. Now, among these numbers, like these are some limited number of configuration 1, 2, 4, 1, 4, 8. There can be many more, like 2, 4, 8, 2, 4, 9, 4, 8, 9. There can be many more, right? Now, among these configuration, it needs you to find the maximum possible minimum distance. Find maximum possible minimum distance. Are you able to understand what I'm trying to say? What is minimum distance here? These distances. A minimum distance in a particular configuration. Now you need to maximize these distances. Maximize the minimum distance. Minimum distance of a configuration. As simple as that. So I hope you are getting my point. What is the problem asking you? Because it's very difficult to understand what is the problem asking you. Otherwise, this is a very cool problem. This is very good problem and very easy problem to understand. The main problem is that students don't realize what is the essence of the problem. What is the problem asking? Because aligning maximum and minimum in the same problem statement is actually very difficult. It's actually very confusing, right? So I hope that is clear to you, right? We want to maximize these minimum distance of a configuration. Now, how to proceed? How to proceed? Let me take it down. So what are the points we have? 1, 2, 4, 8, 9, right? Now tell me, if you are placing three cows, right? What is the minimum answer you can get? What is the minimum answer you can get? Minimum answer. And what is the maximum answer you can get? Minimum answer can be 0. Distance is always greater than equals to 0, we know. Distance is always greater than equal to 0. And what is the maximum distance you can get? Now, maximum distance, I'm not telling you evidently, I'm saying you have three cows. First cow can be placed at 1, second cow can be placed at 9. Let us assume that there is no third cow. Don't forget about third cow. In the case of two cows, what is the maximum distance possible between them? So you will say 1 and 9. That will be two farthest points. That will be 8. So maximum will be 8. That is highest minus lowest, right? And you can say the like this will, for this case it will be 9 minus 1, that is equals to 8. So we are clear that the minimum distance between any two cows can be 0 and the maximum distance can between for configuration can be 8, right? I'm not taking it on three cows. I am taking ideally for two cows, let's say, right? So I hope you're getting my point. Now my saying is that you can go from 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? These are the options. It can be minimum this, maximum this. Now you have to choose what. Now it wants the maximum answer. It wants to maximize the answer, right? So if I say if I'm traveling from this side, if I'm traveling from 8, 7, 6, 5, 4, 3, 2, 1, right? Suppose the answer say that, like the configuration say that 8 is not possible for three cows. Suppose 7 says 7 is not possible for three cows. Suppose 6 says 6 is not possible for three cows. Suppose 5 says 5 is possible for three cows. Then can you say that the answer is 5? What I'm trying to say, 8 is not possible for three cows, placing it in configuration. 7 is again not possible. 6 is again not possible, but 5 is possible. So can you say that I am locking my answer at 5 because I know that the maximum answer can be this one. This is my maximum. This is my minimum. So my answer has to go from minimum to maximum closed intervals, right? I want the maximum answer, so I will start from the right and go towards the left. 8 is not possible, 7 is not possible, 6 is not possible, 5 is possible. If 5 is possible, then it is evident, then 4 will also be possible, 3 will also be possible, 2 will also be possible, 1 will also be possible, 0 will also be possible, right? So 5, I'm saying 5. It can be possible, it is also possible that 0 is not possible. I'm saying 0 is not possible, agreed. But 5 is possible and we need the maximum answer. Maximum answer is 5 only, right? Like maximum answer is 5. So I can stop and I can say 5 is my answer, right? And that's all, right? So let us see. I know that you are getting confused at how will we check whether this is 5 is agreeing the condition or not. But we will proceed to that later. Are you able to understand that 5? How is 5 my maximum answer if it is agreeing the row? Right. Now let us see how do we find that 5 is obeying or not. So our configuration is 1, 2, 4, 8, 9. I have sorted the array given to me. I will not answer why because that is pretty evident, right? I want to go through the number line concept. Now, 1, 2, 4, 8, 9. Suppose the value in hand is 5. Suppose the value in hand is 5. I have to check whether it is possible to keep the minimum distance as 5. To keep minimum distance as 5. Please be with me, please be with me. This is a very crucial step. So, how will we say that we have to keep minimum distance as 5? I will say I have three cows. I have cow number 1, I have cow number 2, I have cow number 3. I will say I can place a cow here, right? Now, this stall is booked. I will come here. 2. I have placed my previous cow at 1. 2 minus 1 equals to 1. Is 1 obeying this decision? Is 5 less, like what I'm trying to say, according to 2 minus 1 equals to 1, minimum distance between them is 1. Minimum distance between them is 1. But I want the minimum distance of 5. So I cannot place here. I will come here. I will say 4 minus 1 equals to 3. Again not obeying. I come to here. 8 minus 1 equals to, what do we say? 8 minus 1 equals to 7. Yes, it is obeying. Minimum distance 5 is getting obeyed here. So I will say I will place one cow here. Because my minimum distance 5, I want to keep every distance which is greater than equals to 5. Okay. I come here 9 minus 8 because the last cow is placed at 8. Because you can see that if I take 9 minus 8 equals to 1, 9 minus 1 is obviously going to be equal greater than equal to 5. Right? 9 minus 1 is equals to 8, which is obviously obeying 5 rule. Right? But 9 minus 8 equals to 1 is not obeying. So I will say at the end that I am not able to place 3 cows because this cow was placed, this cow was placed, this cow was not placed. So I will say 9 is my 5 is not 5 cannot be my answer. Now, to show you how it will work, I want to show you for 3. I want to show you for 3 because I know the answer, so I'm telling you how will it work for 3. So 1, 2, 4, 8, 9. I have 3 cows. 1 cow, 2 cow, 3 cow. I will come here, I will say I can place a cow here because it is not violating my 3 condition. I will come here, 2 minus 1 equals to 1, which is not obeying the 3 condition. I will not place a cow. 4 minus 1 equals to 3, obeying because the minimum distance here is 3. So I will place a cow here. 8. 8 minus 4 equals to 4. Again obeying, I will place a cow here. Now you can see for this particular configuration, distance is 3, distance is 1, and now distance is 4, sorry, 8 minus 4 is 4. As you can see, the minimum distance here is 3, and I can obviously say 3 is a 3, like getting 3 out of a configuration is my correct value, so I can say 3 is my answer. You can check for 4 as well. We checked for 4, it was not. If we check for 5, it is not correct. For 3 it is correct. Let us check for 4 and then you will clear your all doubts. Right? For 4, array is 1, 2, 4, 8, 9. Simple. Right. 3 cows. 1 cow, 2 cow, 3 cow. Come here, place 1. This one is done. 2. 2 minus 1 equals to 1. Not obeying. 4. 4 minus 1 equals to 3. Again not obeying. 8. 8 minus 1 equals to 7. Obeying. So place a cow here. Right? And this is done now. Coming to 9. 9 minus 8 equals to 1. Again not obeying. So I'm able to place 2 cows, but I'm not able to place 1 cow. So what is actually happening? What is actually happening? 4 is not obeying. So 5 was not obeying. 4 was not obeying. 3 is obeying. 3 is obeying. So I will say my answer is 3. My answer is 3. Right? So what is the role we have done? We have just placed the cow wherever it was possible according to the minimum distance. According to minimum distance I want. Right? That is distance can be greater than equals to minimum. Only then I will have to place. If this condition is followed, only then I can place. Right. Now, following that, what did we do? We went from 0 distance, 8 distance, and meanwhile everyone 1, 2, 3, 4, 5, 6, 7. We checked from 8, it was not possible. 7 not possible. 6 not possible. 5 not possible. 4 not possible. 3 possible. As soon as we find 3 possible, we will say done. As soon as we find 3 possible, we say done. Now, if you see, 3 was actually closer from this end. 3 was actually closer from this end than from this end. So we would have saved computation. Because if you see, we will have to traverse the array again and again for every value. For 3 we have to traverse, for 4 we have to traverse, for 5 we have to traverse. So it is taking O of n time. O of n time. Right? O of n time. And let us suppose like it is a n array only, right? It contains n elements, and 1, 2, 3, 4, 5, 6, 7, 8 is the elements we have. So it is taking n times into n. So it is going from O of n square. We need to reduce this. We need to reduce this. How will we reduce it? Now checking out. Now I'm saying my answer can lie between this and this. I need to find a perfect value. Can I use a binary search here? Can I use a binary? Because I know 0, 1, 2, 3, 4, 5, 6, 7, 8 is a sorted, and I need to find a value. I need to find an answer. Find an answer, and that too maximum answer, maximum possible answer, right? So what will I do? I will say my low equals to 0, my high equals to 8, right? We know for the perfect configuration 3 is the answer, right? Now low equals to 0, high equals to 8. What will I do? I will say, see, I will say my mid is equals to 0 plus 8 by 2, which is equals to 4. I will come to 4. I will say minimum distance of 3 was possible. 3 is possible. Minimum distance of 3 is possible. So, is minimum distance of 4 possible? Just tell me a thing. If you placing, like, if, like, go from intuition, I cannot explain this, sorry, but if 3 is possible as a minimum distance, what does it mean? It means that you have a rod, right? You placed one here, then you left 3 units, one, two, three, one rod, one, two, three, one rod, one, two, three, one rod. It was possible. Now, if you want to put this number for 4, you placed one here, you lift one, two, three, 4, 1, 2, 3, 4, 1, 2, 3. You cannot place equal number. So 4 is not possible. So greater number is not possible. So if mid equals to 4 is not possible, what will I do? I will say reduce my high. Because if 4 is not possible, a lower number is possible. So I will say high equals to mid minus 1, which is equals to 3. Right? Now, high equals to mid minus 1, so low equals to 0, high equals to 3. This is the configuration. For this, mid equals to 3 plus 0 by 2, which is equal to 3 by 2, which is equals to 1. Mid equals to 1. Now tell me 3 was possible, right? That means place 1 here, 1, 2, 3, place 1 here, 1, 2, 3, place 1 here, 1, 2, 3, place 1 here. Now going for 1, can I place 4 number of rods with a minimum distance of 1? Yes, 1, 1, 1, 1. Place and left a sort and left a space. That is 1 is possible. 1 is possible. So I will say that if 1 is possible and I need to maximize my answer. I need to maximize my answer. So I can say low equals to mid plus 1. That is, we know that 1 is possible. So lower number of 1 is also possible. But let us check the higher number from 1. That is low equals to mid plus 1, which is equals to 2. So low equals to 2, high equals to 3, and mid equals to 3 plus 2 by 2, which is equals to 2. We will check for 2. Again, it will pass. And then my low will change to 3, my high will change to 3, and my mid will go for 3. And as soon as it returns, my low will change to 4. So 4 comma 3 will end the loop, and my answer will contain 4. My answer will contain 4. So this n, which was from 0 to 8, will go from n to log n. So this particular answer will convert into n log n answer. So I hope that is clear to you. I hope that is clear to you. We use the binary search to go to simplify 0 to 8. Simplify the number of points we are traversing. Simplify the number of points we are checking for. Right? So I hope that is clear to you, and let us now go to the code for it. So let us write the code. As we know that it is nowhere mentioned that stalls are sorted, and we took the fashion is sorted. So let us sort it first. So sort stalls dot begin stalls dot end. My size of the array is stalls dot size. Now lowest distance is possible is 0. Highest distance possible is the far ends, that is n minus 1 minus 0. First and the last. Now while I will also say int answer equals to minus 1. You will know why. So while my low is less than equals to high, what will I do? I will calculate my mid first. So int mid equals to low plus high by 2. If check for stalls mid, that is if this function returns true, then your answer will change to mid, and you will check and your low will go for mid plus 1. That is the check function which we were using, like we were placing 1 cow, then 2 cow, then 3 cow. That if that returns true, that is this answer is particularly right, and this answer is particularly right, then assign the answer and go for the higher values, that is low equals to mid plus 1. Else if this is not returning true, that is that minimum possible distance is not possible, that means we need to shorten our range. So high equals to mid minus 1, and at last return your answer. Right? Now we need to implement the check function. What we will do is it is returning true and false. So bool check vector int and stalls. We are sending it by reference. Int k int mid. Now int count equal to 0. That is the number of cows we have placed up till now, right? And previous equals to minus 1. That is our previous cow was placed at minus 1. That is we have not placed anything now up till now. So for int I equal to 0, I less than stalls dot size I plus plus. When can we place a cow? if my previous equals to 1 1 minus 1, that is we have not placed a cow yet, or if we have placed one there, then stalls of I minus previous, stalls of I minus previous, that is this distance should be greater than equals to mid. It should not be less than then count plus plus. At last, if you are able to place all the cows, so return count greater than equals to mid, right? Let us try to compile and run it. Hope it will run fine and will not give any error. Okay, it is giving an error. So what is actually happening is, so I found the error, we have not assigned it. So because we placed it, that means our previous will now change to stalls of I. Sorry, this is a basic mistake I did. Let us try to compile and run it now. I hope it will run fine. It is not running fine. It is giving an error. Let me see why it is giving an error. I found the error. It will be greater than equals to k. I don't know why I did write k mid. It is just by mistake. Running fine now. Let us try it for submit. And it is getting submitted just fine. So thank you for watching. Hope you liked it. Make sure to like and subscribe to the channel. Thank you. Have a nice day.